Okay, welcome to the next video in our series of the Pinball 2.0 kit. In this video, we're going to be installing our LEDs for our inserts, and specifically, we're going to be using these NeoPixel RGB LEDs. You can buy this one specifically from Fast Hardware, and the Fast controller also has a way to drive those, and then you would use the software, the MPF. We're also going to be looking at using some custom boards that have 3 and 5 LEDs that gives us more creative options in how we light the lenses. It allows us to do little patterns within the lens. It makes the game a little more interesting. All right, I'm going to show you what we're going to do today is we're going to install these and then wire them up. Okay, so first question we would have with our LEDs is how many do we need and which type is going to go in which lens. Now these arrows, 3 will not fit, but a single will fit. So we're going to need at least 5 singles. For the 3/4 lenses, the 5 doesn't fit, but the 3 will. The 3 will fit there. And then for the 1-inch lenses, we could fit a 5. All right, so what we're going to do is we're going to just lay out our boards just to count how many do we have that are singles, how many do we have that are triples, and how many have 5. As I mentioned before, you can purchase these already pre-populated, and I'll link that in the document. These boards, maybe by the time this kit is ready, we will have figured out if someone could actually make these pre-populated. If not, I do have a separate video on how to solder these LEDs to these boards, and I will also put a link in the document where you can actually order these boards directly, and then you could basically fabricate your own. We still need to figure out how many of each, so we're basically going to just, before we make them, we want to make the right amount, so basically just going to put the boards exactly where they go. And so I'll be putting boards, the 3s on the 3/4 inch and the 5s on the 1 inch. I'm just going to go ahead and do that everywhere. Okay, so we've identified where we're going to want the LED boards. So for the 5s, there's a 5 over here. That's 1, 3 here, so 4, 5, 6, 7. So there's only 7 boards that have 5 LEDs. And the ones that have 3 LEDs, we have 10, 15, 16, 17, 18, 19, 20 here. And up here we have another 5, so 25, 26, 27. All right, so 27 3 LED boards and 7 5 LED boards. So if you hadn't already ordered your LEDs, you would multiply that out. They usually comes in packs of 10 from Adafruit. So you would calculate that number and then figure out how many you need to buy. It's usually about $5 for a package of 10. All right, I'm gonna go ahead and solder these up. It's gonna take a little while, and then we'll get back and then we'll start screwing these down and then wire them all up together. Okay, so we've populated all of our LEDs, all of the 3-up boards and the 5-up LED boards. And now it's time to mount these in the locations that they're going to go. All right, but first, what I've done is I made a little map here of where each LED is going to go. And because these are serial LEDs, that means they're going to be daisy chained together. And the problem is each hardware implementation of these LED drivers has a limit to the number of LEDs that can be in the chain. Now in previous builds, I've used a fade candy to drive the LEDs. They no longer make that, but those allowed 64 LEDs to be in a single chain. For this build, we're using the fast version of this LED driver, and they limit the hardware to 32 LEDs per chain. Now, part of that is for logistics, because if you have 32 LEDs and each of them has a connector on it, that means you're going to end up with 64 connectors. And even though it may seem like a connector doesn't have a lot of resistance to it, if you have a string of 64 of those in series, eventually at this current level, you're going to have some voltage drop, which then causes problems with the LEDs. So part of their workaround to make it easier for people so that they don't push the limits on how much voltage drop they might get if they're using connectors is they limit that to 32 LEDs. Now in our case, we're going to be soldering these. So we're not using connectors in this particular, or at least I'm not using connectors in this application, for the exact reason that connectors often create the problem with the bugginess in these serial LEDs. So normally that effect would not matter to me, the drop, but we are limited to 32 LEDs. So what I've done here is I've mapped out patterns of 32 or less LEDs, and it looks like we have at least 4 different strings, independent strings, and then we also have LEDs for these bumpers, separate channels. All right, now the reason we want to map these out is because it's going to change how we orient our LEDs on here. So for instance, we have a set of a bank of 3-up LEDs that are going to go here, and we know from our map that we're going to want to run these in a circuit, which means that we're probably going to want to have these LEDs facing this direction, right? And so we can either mount it to the inside like this or to the outside. I'm inclined to think that we may want it to the inside. And the reason is, if we have 2 of these here, let's say that we're looking at this here, if these are pointed outwards, well, it's not too bad, but we are kind of close to this mechanism, whereas if we put them to the inside, we're sort of tightening up this space. Okay, so the idea is if you've mapped these out already, and it gives you an idea of where the wire's coming from and where the wire's going to, which might change how you orient your boards in these particular lenses. All right, so I'm going to start doing that for all of the strings, all the channels that I've mapped out so far. Okay, here's the first example with these single LED boards. So I've mapped this out so it comes across the arrows and then up to this lens over here. And so you can see that this particular board only has a single input and a single output, and we're inputting this side. So for instance, instead of mounting the board this way, we want to mount the board this way, so we're coming in and then out and then in, out. And so we're just going to be jumpering from here to here, here to here, here to here, here to here. All right, so this is going to be the correct orientation for this layout going this way. All right. Okay, another example on this same line. We're coming up into this 5 over to this 3, and then from here we're going to go to this, and it's going to go in a loop and then come over to this one. And so when we mount these, we're going to want these to flow in this direction, and we wouldn't want to do this. This is going to be a little bit tight if we try to put these all to the middle. So we're going to screw them to the outside, or we're going to have them aimed so these connections kind of go this way. So it kind of makes a loop. And then we're going to come from here, we're going to come over to this one. One thing also to notice is a little bit different on these custom board designs. Even though I have an arrow for an in and an out, they have the connection on both sides. So in theory, you don't necessarily have to use that pin where that arrow is. You could actually use this one. So I could actually flip this if I wanted to and actually come in here and then out there. All right, so this is symmetric because we have 4 connections, which is slightly different than on the single LED board where you only have one pin for input on one side and one pin for input on the other. This gives you a little more flexibility because you can then rotate it backwards or forwards, which gives you a little more mounting option. Okay, we've got all the LEDs laid out where you want them. Notice a couple things, like there's certain positions where there's no alternative to the positioning of that, so we just have to go with what it is. But you could always come in from either side and out either side. Similar situation over here. These need to be mounted here just because it's too tight, even though the wires are going to flow this way. And then this one down here, according to our chart, the LED is going to come in from here to this one, and then this is going to come back over to here, and then this is going to come out. So we're going to mount these this way. And notice too, I've also angled these a little bit because this is going to come down and then over and then back up. All right, now we're going to screw these down and then move on to the next step. Okay, if you've watched some of the earlier videos, you know that this is sort of my go-to screw for anything that goes into the playfield. It's a number 6 sheet metal screw pan head with a Phillips. The most important thing is that it's 3/8 inch long. Now all the playfields are going to be 1/2 inch thick, and so by going with the 3/8, I'm guaranteed to not accidentally poke through to the bottom. So I'll have like hundreds of these within arm's reach. Everything else I keep safely away in containers. All right, so what we're going to do is also, we're not going to, you'll see some some marks here for where you would put dimples. I don't want to drill a pilot into this wood for the same reason. You don't want to accidentally poke a hole through the front. But what we will do is, with this type of screw, we can actually just drill straight in. Now the key also is that you want to make sure that these are centered, because these boards are designed with the holes. It's designed for number 6. Okay, so you want to make sure that the mounting holes are not going to be too close to the edge. With these 3 up, these are sort of self-centering, so they'll always be far enough away. With the 5, there's a little bit of wiggle room. This connector, the pads, are directly above the center, so you can line that up by using that as a reference, and that puts this about an 1/8 inch or maybe more, 3/16 off of the edge of this lens. So that should be enough. And then what we're going to do is we're just going to drill this straight in to the wood. No need for a pilot hole. Like so. You could probably get away with just doing one screw here. A lot of cases I would use 2, but I'm going to I'm going to go ahead and put 2 in here. I think you could get away with 1 if you had to. All right. So that's basically it. I'm going to go ahead and I'm going to screw all of these down, and then we'll come back, and the next step will be starting to wire these up. All right, before we get to wiring, I want to explain a couple things. And first is about the color code we're going to use for this. Now, as you can see, for our coils, we have red and black, which is standard, typical, except in our case, red is high voltage, and we don't want to accidentally mix high voltage with the low voltage here, which is going to be 5 to 6 volts. And so the color code I usually use for low voltage, and this has been over like the last 20 years or so, you don't have to use this color code, but it's one I've been using for a long time, so I'm going to stick with that. But for low voltage, I use orange and black for 5 volts and ground. Now, for this, I'm going to modify this a little bit for a couple of reasons. One is that our serial LED strings are going to be sensitive to noise, and we don't want to accidentally tap into that 5 volts for something else with the risk of creating a ground loop that will induce noise into our serial line. So for the LEDs specifically, I'm going to do a different color. I'm not going to use orange, I'm going to use pink. And for the serial line, typically I would use white for signal. So what my wire is going to look like for these serial LEDs is going to be black for ground, pink for 5 volts, and white for signal. Now I'm also going to have, there's going to be 5 volts running here with the for the GI lighting, and for similar reasons, so here I can use orange for the GI lighting, and I can wire it directly to the socket. But now the ground on the socket is actually a switched ground. So for similar reasons, I don't want to tap into, if I did black and orange, I might accidentally tap into that thinking it was ground when it's actually running to a MOSFET. So for the GI lighting, I'm going to use orange and purple. Now, one other thing we're going to do is we're going to twist these wires. A lot of people use twisted pair to reduce noise. That is valid, but we're mainly going to twist these wires because it makes it easier to manage. And we're going to do that, I'll show you real quick, we're going to do that with a drill, and we're going to twist up like a big long string and just cut from that. But it makes the wire management a lot easier when these things are twisted together. Okay, I've cut about 3 feet of each color wire, and then what I'm going to do is I'm just going to twist a little bit on this end here. And I'm twisting it, if you're looking at it this way, I'm twisting it clockwise. And then we'll put it into the drill. We've got the drill going in the forward direction, the normal direction. We basically just hold on to this and then turn the drill on. All right, when it's about that tight, just let this end go. All right, now we have a twisted wire. I usually cut off this end where it's been crunched because you can't really trust that. And then this end's good. Okay, so now we have our twisted wire, and again, some people do this for noise reduction, but we're mainly doing it just makes it easier for wire management. All right, and we'll do the same for this when we end up doing the GI lighting. All right, I'm going to show you one example before I do the whole thing. We'll reference our map that we made previously, and we're going to do from this one to this one here, which is this LED to this LED. Keep in mind this is the right side, so the playfield's flipped, so we're looking at it as if it were on the left. And we want to go, our arrows are showing that we're going from this to this, so this is the output to this input, and that means we're going to go to that input, and basically what we'll do is we'll just sort of measure out the wire, give ourselves like a little bit of a loop. We don't want to go straight. Give ourselves a little bit of a service loop. Cut this wire. Then we'll strip the ends like this. Then after we strip the end, I like to give it just a little bit of twist to make sure that all of the strands are together. Alright, we're stripping it like maybe 3/16, an 1/8 inch to 1/4 inch, so 3/16 is about what we want. Alright, and then we're going to tin this. I got my soldering station here. We're going to tin it, and by tin, it means we're going to apply some solder to the wires themselves before we actually solder it to the pads. So we tin the ends of these like this. Then similarly, we're gonna tin the pads of our board. You notice here I have these labeled. DI is for N, data N, V plus is voltage, and G is ground. So I've tinned the N, the voltage, and the ground. And on this one, remember that we're using the out, so we can tin D out. DO is D out, ground, voltage. And now we just heat up the pad while our wire is on it. White is data, black is ground, and we're using pink for voltage. Okay. All right, and then we do the same for this one. White is data, so DN. Get these wires straight. Okay, voltage is pink. And black is ground. Okay. All right, so now we have a nice tight wire bundle here. As this starts to build up, we may put a cable clamp here to hold this down, but we're not going to do that until we have all of our wiring in place and we know where all the wires are going to go. All right, I'm going to do that same thing we just did, where we're following our map, and then we're going to do all of these LEDs. Okay, before I get too far on the LEDs, I also want to go over the GI lighting, and that's going to take a while to finish all of that. So we're going to call that the end of this video, and then I'll post that, and then we'll move on after finishing all of that. But let me do the GI lighting. And also on these LEDs, you'll notice I didn't go just straight from here to here. I gave a little bit of a loop here. That's in case we have to come back and for whatever reason cut this and resolder it. We'll have a little bit of a service loop. But for the GI lighting, this is a bulb we're going to use. Traditionally in Pinball, the outside is power and the center is going to be the switched ground, which is sometimes that's reversed how you might see in other industries. So keep that in mind. The outside is the 5 volts, which means that this pin that's connected to the center is going to be ground, and the outside shell is going to be power. Again, we want to sort of like measure out what our length is, and what I like to do is go straight up and then back down. So our service loop is going to be this up and down, and then create a little path over to here, and then again up and down. So that's our wire. All right, and we cut it to that length like that. Now same thing, we will strip this and tin it. Give it a little twist. Okay, that's stripped. We'll tin the ends. And tinning again just means we're just going to put a little bit of solder on there. Alright. We also want to tin the tabs on the base, the bayonet base. All right, and we'll tin this one. Okay, and then now to solder it, we're just going to basically remelt the solder that we tinned on each of these. So power goes to the outside of the base, and our purple wire, which is going to be the switched ground through the MOSFET, is going to go to the center. Same over here. The switched ground is in the center. Power to the outside. Okay. And then again, once we get all of our wiring in place, we'll come back and start tying this down, but we want to sort of wait until all of our wires are in place, because like for instance these switches will also similarly have wires coming off of them, and we want them to run on along similar paths to wherever they're going. All right, that's going to be it for this video. Once I've done all of these wiring of the LEDs and the GI lighting, we'll come back to the next video. All right, stay tuned for that, and thank you for watching.